Hello everybody, my name is John Larsen and I would like to tell you or show how to use Eagle to create a schematic that can later be used for producing a PCB. I have here in front of me the Eagle control panel. It's the first thing you see when you open Eagle, and well, it has a lot of things of course, but yeah, well, you have some documentation, libraries of components, design rules, etc., etc. What is most interesting now is down here on the projects. You have your Eagle projects, and well, since this is a completely new installation, I have currently no projects. And then we have an example folder with a lot of different example projects that you can open and browse through. And we will look at one of them a bit later. Um, the first thing to do and what is normally, well, considered for me to be the best way of doing it is to create a project first. So whatever you're doing, you would always like to keep it inside a project. So start by right clicking and say new project. This project we could call LM7805 power, since what we are going to do is building a simple power supply for the LM7805. So now we have an empty project, so we right click again, and under new we find schematic. Click on this and you will be presented with the schematic viewer. First of all, we start by saving things so that we have things saved properly. So well, we call it 7805 power supply. Okay, so now we need to add some components here. The first thing we want to do is to add the linear regulator chip. So what we do is we go to here to add, which open up our component library like this. And as you can see, the content of this is immense. So you don't want to go browse here and try to find it. You really want to do the search here. So we'll do a star LM7805 star end. And we get our linear device linear devices in Series 8 series, and a lot of them. As you can see here, we have our 7805 in different versions, and these versions, the difference between them is the packaging. So we have here a package, it's the TO220, which is horizontal, and we have it in vertical. You would also find normally you would be using that the TO92. These are the most standard to use. In this case, we will use the vertical. You could use the horizontal as well, and since this will be put plain on the PCB, you could use a piece of PCB around here to use as a heatsink. But well, in this case, we'll use it vertically. So, whoops, this is fine. So we say OK, and we get our schematic component, and we just click to place. We need to add a few more components, so we press escape. We need a few capacitors. Oh, not with the S. And you get quite a long list, but since we don't have any specific requirements to our capacitor, we're just going down here with the standard ones. Still with a lot of opportunities, they are still in different packages. And since this is not a simulation tool, there's no difference between the capacitors. It's only the footprint that's differ. But nevertheless, you want to choose the right footprint, otherwise your PCB will be wrong in terms of of how you want to mount your components. So here you can see the diameter of the capacitor. So you want to keep eye on this because that tells you a bit about how the pitch are between the pins. So in this case, we'll just select this one, press OK, and we will add these two capacitors to our schematic design, like this. Then we need also a flyback diode, and in this case I'll just put in the name of the diode we are going to use, and then in this case you see you don't get a result. So if we put the stars in front and back, we get a direct hit with two different footprints, and I'll just go use this one. To rotate a component, you right click on while having it in focus like this, you just right click and you rotate the component, and we put it like this. Now we have the basic components at least. Now we need to have connections to put on the side of the PCB in order to connect wires to the power supply. So we escape again, and here if you just write connector, you get an extremely long list, which takes a bit of time to go through. In our case, we normally can get around using these M0 2, for instance, or they come in 08 packages as well, or I think we can get them in 10. Yeah, so they come in a number of pins, and they work quite well with standard pin headers, the pitch matches. But we will just be using M2 here. So okay, and we can place this component here and here. The last thing we want to add is VCC and ground pins. This might look a little strange, but it will make sense in just a few minutes. So firstly, escape, and we will add a VCC. And we will putting a few of them here. So here, 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 and here. And we will also add a ground, GND, like this. So these two I need to move up a little bit, so I'll take hold of my move tool over here and just move them up one step like this. So now we need to connect everything here. And we go over here and grab the wire tool and then click and connect them. And in order to release the wire, you just press escape and ground up here. Whenever you're clicking, you're doing a corner. And here you see how it nicely connects. And I'm going to add one of these here and here. So, oh, I'm missing one thing. I'm missing the diode. So now we have our power supply put together. What you can see is that we have ground pins down here and we have VCC pins up here. So all of these VCC pins attach these wires up here to the same grid. So if we look at the names, so go info up here and click on the wire, you can see that the name of the wire is VCC, and the same is the case over here, and over here. This effectively means that all of these wires are connected together, meaning that we will short circuit this, or at least remove its functionality, since we will have the input here and the output connected directly over this. So this will not work. We need to separate this VCC grid from this VCC grid. And what you do is you go here over here with the naming and click on the wire. And instead of VCC, we can call this 15 volts, for instance, which might be what we want to put on the input. And we also want to give this the name of 15 volts. And it asks us to connect VCC and 15 volts, and we say yes. So if we look now, here it says 15 volts, here, here, and all the pins here are 15 volt pins now. At the other side, they say VCC, so they have been separated now. But a good thing is to take a hold here as well, and then call this 5 volt, because then we have a clear separation. Yes. So if we again take here, you can see that these 5 volt, yeah. Yes. Up here we are still missing the names of these. They're still saying VCC. So we could instead call these 15 volts. And then these 5 volts. So this means that these pins are connected into one grid, and these pins are connected into some other grid, another grid. In this case, this is a little bit overkill since it's such a simple diagram. But if we just save here and close, and then have a look at one of our examples, for instance, this Arduino board, which is a bit more complicated, you can see they're doing exactly the same. For instance, down here, by the way, I'm zooming by scrolling. You can see they both have a plus 5 volt and a plus 3.3 volts net and a ground. And they're using this to maintain a clear diagram that's easy to read, because they don't have to route they don't have to draw all the power pins around in the circuit. They can just have these references, and then the software will handle the connection and make sure that all these pins and nets with these names are routed together when you go to the PCB layout system. So it really makes the diagram much easier to read, because you don't have to follow all the lines of power net. So that's the reason for it. One thing more I would like to show is that, well, again, this is a simple system, so it's easy to see, but say that you have a lot of different components that you want to put into the same PCB, you also need to draw them on the same schematic. And to make it more clear what goes where and which modules or which group of components are doing what, you can simply put a wire around a block of components like this, and then add a text. For instance, in this case, power supply. So whenever reading the diagram, this is much easier to comprehend. You can easily see, well, these blocks of component is the power supply, etc., etc. And given that you are forming power grids like this, you're removing a lot of wires going in and out of all of these boxes, making the diagram easy to read. So this is really recommendable. And this box, I drew that with just the wire tool over here, and then inserting the text using the text. So this were a little guide on how to do a diagram using Eagle. The next thing we will look at in the next video is how to take this diagram and form it into a PCB. Also within Eagle. It's mostly a click operation to get it into the PCB design view, and then you need to move the components around and route the connections between the components, but more on that in the next video. So thank you for now. Bye bye.